Welcome to Math with Professor V. This is video lecture for section 2.2 for business calculus or brief calculus on quadratic functions. Now, a quadratic function is defined by the following equation. We have f of x, sometimes you'll see it written as y, equals ax squared plus bx plus c, where a, b, and c are real numbers and a cannot be 0. So the key is this term has to be there. In order for something to be a quadratic function, you need an x squared term. So previously we were looking at linear functions. Those functions had only x to the first power. Now we're spicing things up. We've got x squareds in there. The graph of a quadratic function is called a parabola. So hopefully you're familiar with what a parabola is. It's a U-shaped graph. And the ones that are functions either open upwards or downwards. The lowest or highest point on a parabola is called the vertex. So the vertex would be either its minimum or its maximum point. And parabolas are symmetric with respect to the axis of symmetry. So basically the axis of symmetry is a vertical line that cuts the parabola right down the middle. And it's symmetric. If you were to reflect one half over that axis of symmetry, boom, you get the other half. We're going to use that to our advantage when we graph. You'll see in just a minute, because it'll be a nice way for us to get additional points on our graph without doing much work. So that's precisely what we're going to focus on right now, graphing quadratic functions, graphing parabolas. And here's the characteristics that you need to pay attention to. So the first thing is you look at the coefficient on x squared, you look at that a value. If it's positive, the parabola is opening upward. If it's negative, the parabola is opening downward. All right, so that'll tell you which direction the parabola is facing. The y-intercept is at 0, c. C is the constant right here. If you forget this, it's no big deal because we know we find y-intercepts by substituting in 0 for x. So if you just put 0 here, they go bye-bye. That's why all you have is c. Okay, the x-intercepts, remember that's where the graph crosses the x-axis. If they exist, they occur where f of x equals 0. So you set the whole function, or you set y equal to 0, and you're going to solve for x. Notice it did say if they exist, because sometimes we won't have any x-intercepts for certain parabolas. And don't you worry, we have an example like that coming up so you can see what that situation looks like. Okay, the vertex is a very important point. Remember earlier we mentioned it's either the min or the max of the parabola. That's a key feature you need to find before you start graphing. How do you find it? You can use the following formula. The vertex's coordinates, because remember it's an ordered pair. Here's the x coordinate of the vertex, here's the y coordinate of the vertex. The x coordinate of the vertex is given by negative b over 2a. The same a and b right here that we were looking at earlier. And since the vertex is such a special point, we don't usually call it xy, the vertex. It got its own set of letters, believe it or not. The vertex we refer to as h, k. All right, so when you're finding h, you set it equal to negative b over 2a, or the opposite of b over 2a, because sometimes b is already negative, you know. And then to get k, you just plug in whatever h was for x into the function. So we'll practice that together. Key thing to remember, h equals negative b over 2a. Vertex is at h, k. All right. And then the axis of symmetry is given by x equals negative b over 2a. Another way of saying that is x equals h. So remember when we were graphing lines, if the equation is x equals something, that's the equation of a vertical line. Remember, y equals something, then that's a horizontal line. And you can see here the axis of symmetry is vertical, so that's why it's x equals, and it's always going to be h, whatever the x coordinate of the vertex is. Okay, that was a lot of information, I know. So we're just going to practice applying all of these new terms and properties as we graph. Okay, here we go. So graph the parabola, give its vertex, axis of symmetry, x-intercepts, and y-intercept. So here they said y equals x squared plus 4x minus 5. A lot of the times I will be using function notation. I mean, we're going to be working up to doing calculus, and it's important that you're comfortable with it. So I'm going to rename this little guy f of x equals x squared plus 4x minus 5. It's the same thing, okay? Can you tell me which way this parabola is opening just by looking at the equation? Good, yes, it opens upward. Okay, how did we know that? A, the coefficient on x squared is positive 1, right? So then that's, since it's not a negative number, it's positive, it's opening upward. Okay, first thing, let's go down the list. We need to find the vertex. Okay, so the vertex, remember, is h comma k. How do we find h? Here, I'll scroll down so you can look up above. You see the formula right there? Negative b over 2a. And what are a and b? A is 1, b is 4. So here we go. Negative 4 over 2 times 1. That's negative 4 over 2, negative 2. So that's the x coordinate of the vertex. I need to find k, its little partner in crime, the y coordinate that goes with it. So what do? I'm just going to plug in. Let me tell the people I'm finding k, which is f of negative 2. So I'm simply substituting or plugging in negative 2 for x into the original function, the equation of the parabola. Be careful with parentheses. So you have negative 2, close the parentheses, the squared goes outside, yeah? Plus 4 times negative 2 minus 5. So this is 4 minus 8 minus 5, negative 4 minus 5, negative 9. So what I would say is write the vertex now. We've got it. It's negative 2 comma negative 9. That's my ordered pair. That's HK. And then we can also tell people where the axis of symmetry is. And please abbreviate. Whew. Okay, axis of symmetry is always x equals h. Don't just write a number. Oh, no. X equals negative 2. There you go. There you go. All right. How are we doing? Well, let's plot those two for now. Negative 2, negative 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's right here. That's the vertex. And then axis of symmetry, negative 2. It's this vertical line. This was a little too chunky. Okay. Good. So I did vertex, axis of symmetry. Now we need x-intercepts. To get x-intercepts, you set the function or you set y equal to 0. So we have 0 equals x squared plus 4x minus 5. Oh, someone took mercy on our souls, this factors. So 0 equals x plus 5 times x minus 1. So we have x plus 5 is 0 or x minus 1 is 0. So then we end up with either x equals negative 5 or 1. Don't leave it like that. Oh, no, no, no. You have to write them as ordered pairs. So x-intercepts are negative 5, 0, 1, 0. Okay. Oh, that was not what I wanted. There we go. And then the y-intercept you get by substituting in 0 for x, or you could just, boop, look at what c is, negative 5. So 0, negative 5. And then we're ready to graph. So here we go. 0, negative 5, 1, 2, 3, 4, 5 is right there. And then the x-intercepts 1, 0, negative 5, 0. Now, I like to have the same number of points on my parabola on each side of the axis of symmetry. So what do I mean? Here's the axis of symmetry. You can probably already see, right? It's got this U shape. But here on this side, we have 2 points. Over here, we only have 1. So I would like one more point over here so it matches. And what you can do is just take that y-intercept and reflect it on the other side. Remember, this is our symmetry line. So you can fold the graph there and it will be symmetric. So this y-intercept, 0, negative 5, is 2 units away from the axis of symmetry. So you just go 2 units over this way and you have another point. If anyone cares, that's negative 4, negative 5. Okay, now I feel good. I'm like, all right, I got the same number of points on both sides. Don't forget your arrows, otherwise it's wrong. Remember when we did domain and range in the previous lesson? not having arrows means the graph stops. So if it doesn't stop, you have to indicate. Did we do everything they wanted from us? X-intercept, Y-intercept, and we graphed it. Yes. Perfect. A+. Okay, how was that one? Good? Okay, let's look at some more examples. So here we have y equals negative 3x squared minus 6x plus 4. Can you tell me which way it's going to open? Yeah, this one opens down because a is negative. This one opens down. Okay, so let's start off. Let's get the vertex. So h is equal to negative b over 2a. So that's negative 6 over 2 times negative 3. What is that? 6 over negative 6, which is negative 1. And then k, I get k by plugging in negative 1 for x. So f of negative 1. So negative 3 times negative 1 squared minus 6 times negative 1 plus 4. What's this going to be? This is going to be positive 1 times negative 3. That's still negative 3. Plus 6 is 3. Plus 4 is 7. Okay, so we could say the vertex is at negative 1 comma 7. And also the axis of symmetry is at x equals negative 1. Excellent. We can graph those now, or let's just wait and graph everything at the end. Okay, next thing we need are x-intercepts. So you set the function, or you set y equal to 0. So 0 equals negative 3x squared minus 6x plus 4. This is a good time to point out something. When you're solving a quadratic equation, if the coefficient on x squared is ever negative, change it. Whether you're going to factor or do the quadratic formula, it's nasty if a is negative. So in this case, you can multiply everything by negative 1, or you could think I'm going to move all the terms from the right side of the equation to the left side. It's all the same thing, okay? But don't think, oh, I'm just going to leave it and carry on with the negative. I don't feel like moving things around. No, it's going to make life so difficult. Please don't. So we have 3x squared plus 6x minus 4 is 0. And then you're going to sit there and try to factor, and try as you might, your efforts will be in vain. I'm so sorry. So it's time to bust out the quadratic formula. If you need practice with the quadratic formula, I have another short video, so I'll link it here. Just click in the top right, and I'll put it in the description. So x equals opposite of b plus or minus square root b squared minus 4ac all over 2a, all over 6. So what is this? Negative 6 plus or minus square root. That's 36. And then this will make it plus 16 times 3, 48. 36 plus 48, 84. Over 6. Does square root of 84 simplify? Yeah, because 84, what's the largest perfect square that goes into 84? It's 4, right? 4 times 21. So you could break that up into square root of 4, square root of 21. So this is negative 6 plus or minus 2 root 21 over 6. And then we can further simplify, because 6, 2, 6, I can cancel out a 2 from everybody. But oftentimes this is a dangerous moment for students. So I'm going to encourage you, just look at the numerator. I can take a 2 out of both these guys. That's how I'm going to start. Then you have negative 3 plus or minus rad 21 over 6. Then cancel, and this is a 3, and we've done it safely. I'd say the number one thing is students get way too excited and they go, boom, boom, I'm going to cancel and make this a 1. But then what about this poor 2? You can't just neglect him on the wayside. No. All right, so then the x-intercept we have, this is the exact answer, negative 3 plus or minus rad 21 over 3. So if you're reporting what the x-intercepts are and the directions don't say round to 3 decimal places, this is the answer you would give. I'll show you right now. I would write it like this, ugly as it may be, as an ordered pair. Negative 3 plus or minus rad 21 over 3, comma 0. okay? If they don't ask for anything else, then that's it, you stop. Sometimes they'll say, now put it in the calculator, round to however many decimal places. So pretend they did that. Practice using your calculator. You should get 0.528, comma 0 and negative 2.523, comma 0. That's helpful in case, like for the graphing moment right now. If you told me graph negative 3 plus rad 21 over 3, I would know, where that is. And then the only other thing we need before we graph is the y-intercept. So you plug in 0 for x, or you just look at what c is. It's right there. So the y-intercept is 0, 4. Very good. So let's put it all together. I'm going to first put axis of symmetry, x equals negative 1 right here. Vertex is at negative 1, positive 7. So negative 1, 1, 2, 3, 4, 5, 6, 7. Okay. Like I lost track. 1, 2, 3, 4, 5, 6, 7. Okay, right here. Then y-intercept is at 0, 4. 0, 1, 2, 3, 4. Let's reflect it over to the other side. There's negative 2, 4 just for good measure. 0.528. No one's going to know. Like, just get it close to 0.5 and that's good enough. Call it a day. Negative 2.523. Who cares? Just negative 2.5 is good enough. You think anyone's going to notice? No. Okay, then here's this little downward facing parabola. Do your best to make it curved and U-shaped, not too pointy. Mine's a little pointy. Should we improve? Yeah, let's do better. Oh, that's a little better. You don't want to confuse it with later. The graph of absolute value of x, it's a V shape, very sharp. So I don't want my parabolas to look too much like that. What an insult to them. Okay, how was that? I know, not as pretty and clean as the previous one, but it is what it is. They exist. Okay, next one, example C. Please don't have a meltdown just because there's fractions. Okay, you guys keep it under control. Don't let your brain go into shut-off mode. I think that happens too often with students. Oh, okay, they're fractions. It's fine. I got this. Can you tell me which way the parabola is opening? Very good. It opens down. How do we know? Because look at A is negative 1/2. Negative. So let's go ahead. Let's get the vertex. So do you remember H's formula? Negative B over 2A. Good. So that's negative, B is negative 1 over 2 times A, 2 times negative 1/2. So that's 1 over negative 1, which is negative 1. Hey, that's what H was last time, last example. Okay, then K is F of negative 1. Do this carefully. Negative 1/2 times negative 1 squared. The exponent goes outside the parentheses. Minus negative 1 minus 7/2. Negative 1 squared is positive 1. Times negative 1/2 is still negative 1/2. Then this is plus 1 minus 7/2. So negative 1/2, negative 7/2. That's negative 8/2, better known as negative 4. Plus 1, negative 3. Boom. So vertex is at negative 1, negative 3. Can you tell me where the axis of symmetry is? Yes, x equals negative 1. Beautiful. Okay, that's done. Now let's go ahead and get the x-intercepts. I'm going to set the function or set y equal to 0. And then this is going to build on something I mentioned in the last example. So for sure, we don't want a negative in front of our x squared. I'm also not thrilled about solving an equation with fractions in it. You shouldn't be thrilled either. Get rid of them. So I can do both things in one step. I can get rid of the negative and get rid of the fractions if I multiply this entire equation by negative 2. So 0 times negative 2 stays 0. Now negative 1/2 x squared times negative 2 becomes positive 1x squared. Then I'm going to have positive 2x plus 7. Oh, much better. Don't you just feel relieved already looking at this thing? So much more friendly. But I have bad news. It doesn't factor. I'm so sorry. So it's time for that quadratic formula again. X equals opposite of b plus or minus square root b squared minus 4ac all over 2a. And then look underneath the radical. This is 4 minus 28. So that's -2 plus or minus square root -24 over 2. And if I continue simplifying, I'm going to have to use the imaginary unit I, which means that there's no real solution here. There are no x-intercepts. As soon as you notice there's a negative underneath the radical in the quadratic formula, this stuff, the b squared minus 4ac, is called the discriminant. So as soon as you notice the discriminant is negative, it means there's no x-intercepts. Okay. Oh, too bad for us. Do we at least have a y-intercept? Yes, we do. So it's going to be 0, c or 0, -7/2, which is -3.5. That'll be easier to think of when we graph. Okay. So it's not our fault. Don't feel badly. There's no x-intercept. Axis of symmetry, x equals -1. Here we go. Vertex is at -1, -3. And then y-intercept 0, -7/2. It's not good. No, no, no. You should not draw a parabola with any less than 3 points. One of them needs to be the vertex. So for this one, definitely we have to reflect the y-intercept to the other side. This point is -2, -7/2. Okay, that's important. Here it is, opening downward. Okay, good. I hate it. I'm sorry. One of the ugliest parabolas I ever did draw. Okay, I think this should be better. Oh, much improved. Okay. Not my favorite, but it's still good. Okay, that's that. So now that we're professional at graphing parabolas, let's go ahead and do some applications with this idea. So let C of x equal 16x plus 24. That's the cost to produce x batches of widgets. And let R of x equal -4x squared plus 36. That's the revenue. And both are being measured in thousands of dollars. So part A says graph both functions. So notice they gave me a little graph here. We're just going to stay in the first quadrant where the x and y values are positive because we're doing a real world application. It wouldn't make sense to have negative quantities or prices of things. So here's x. And then I'm going to graph C of x and R of x, on the same graph. Very good. Start with the harder one. Let's start graphing R of x. Part A, graph both functions. So R of x is -4x squared plus 36. It's a parabola opening downward. Very good. Yes. I know there is no x term, right? B is 0. It's fine. We're good. So we can go ahead. Let's find the vertex. H equals -b, which is 0 over 2a, 2 times -4. So 0 over -8, that's 0. So the vertex is at 0, 36, which is also our y-intercept. Okay. And then the only other thing I would say let's find are the x-intercepts. So I'm going to set R of x equal to 0. So 0 equals -4x squared plus 36. Now, since there's no x term, x to the first, we can actually solve this a little differently. I'm going to use the square root property. So I'm going to move the -4x squared to the other side, divide by 4 on both sides, and then I get, if I take the square root of both sides, x is plus or minus 3. But remember, we're not using any negative x values because x represents batches of widgets. You're not going to make negative quantities of things. So only 3, 0 is our x-intercept. And then vertex, which is also our y-intercept, is at 0, 36. Okay. Then I also need to graph the cost function, where are you? C of x is right here. 16x plus 24. That's going to be a line because it's a linear function. We only have x to the first. So let's write down C of x is 16x plus 24. 24 is b. Remember, this is in y equals mx plus b form. So my y-intercept is 0, 24. And my slope m is 16. Let's think of it as 16 over 1. So we can count rise over run really nicely. Okay. So let's see. We have to scale like all the way up to 36. So let's say each of these tick marks is going to be 4. So I'm going to indicate that. This one's 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, etc. I only marked off the ones that were relevant for us, like 24 because the y-intercept, 36 for this y-intercept. If you want to add more all the way up, I just don't like it. It gets messy. Okay. And then for the x-axis, we only need to go as far out as 3. So I'll just say each one of those is a half. I'll say this is 1, 2, 3. Just so my graph isn't so squished. You could spread it out even more, honestly. You could say this is 1, this is 2, this is, have at it. So here we go. Let's graph the parabola first. It's going to go through 0, 36. And then it also has x-intercept 3, 0. So just make a curved shape connecting those 2 points. That's r of x. And then the cost function c of x, y-intercept is 0, 24. And then the slope is 16 over 1. Now keep in mind each of these is 4. So if I rise 16, I'm going to go up 4 from this point. 1, 2, 3, 4, because that's 16 over 1. Remember, I'm counting by halves in the x direction. 2, 3, 4, right here. So here's my cost function. And it keeps going up, up, up. This is c of x. Good? Looks nice. Find the minimum break-even quantity. So remember, break-even quantity occurs when revenue is equal to cost. So I'm going to set these two functions equal to each other. Negative 4x squared plus 36 equals 16x plus 24. Okay, this is a quadratic equation. So let me set it equal to 0. Let's move everything to the left. So negative 4x squared minus 16x, 36 minus 24 plus 12 is 0. I definitely want to make this positive. And then I notice I can divide everybody by 4. So let's divide everybody by negative 4. That way I'll make the first term positive and reduce everything. So this is x squared plus 4x minus 3 equals 0. And this one might fake you out and look like it factors, but it doesn't. I'm so sorry. If it was a plus 3, it would. So yeah, it's quadratic formula time. So x equals opposite of b plus or minus square root. You know what? I need a little more space. Just make that tinier. Okay. So then we have negative 4 plus or minus square root b squared. That's going to be 16 minus 4ac all over 2 times 1. So what is this? Negative 4 plus or minus square root. Negative 16 plus 12, that's 28 over 2. 28 is 4 times 7. So this is going to simplify to negative 4 plus or minus 2 rad 7 over 2. And then you can cancel the 2 out from the numerator, but you got to do it from everybody. So here, and that negative 4 becomes a negative 2 now. So we have negative 2 plus or minus rad 7. Now both answers won't make sense because negative 2 minus rad 7 is going to be negative. And x is the quantity, that's batches of widgets, so it wouldn't make sense for it to be negative. So we'll throw that one out. If you need to punch it in your calculator to see, this will be approximately positive 0.646, and then the other one is negative 4.646. So that one gets thrown out. Only positive 0.646 is part of our answer, which corresponds with -2 plus rad 7. So that's the break-even quantity. We actually can see it on our graph. It's right here. Oh my goodness, what stunning accuracy. Look at that. Look. You know why I'm so excited? Because remember, this is a half. That definitely looks like it's at 0.646. Whew, look at us go. But see, we needed algebra to find it. If we relied on the graph, you would have never guessed. Oh, that looks like -2 plus rad 7 to me. No, certainly not. Okay, very good. Next, we're asked to find the maximum revenue. So here's my revenue function. You could probably see the max is right here. If you didn't have the graph already, no big deal. You look at revenue, you go, it's a parabola opening downwards. The max always occurs at the vertex. That's something to remember. So I'll write that down for you. The max of any quadratic function that's opening downwards, it should make sense, right? If it's going like this, the max of R of x is at the vertex, always. So the vertex is at 0.36. We already found that. So the maximum revenue is 36, but they told me revenue is being measured in thousands of dollars. So this is 36,000. That's the max revenue. Okay. Last, they asked us to find the max profit. Okay, do you remember formula for profit? Capital P of X is revenue minus cost. Okay, so this is revenue was -4x squared plus 36 minus cost is 16x plus 24. Don't forget to put parentheses here because this minus sign has to distribute. So this is -4x squared plus 36 minus 16x minus 24. So let me just clean things up. P of x is -4x squared minus 16x, and then 36 minus 24 plus 12. Okay, so again, P of x, why is this guy floating? Come back down. P of x is a quadratic function. How do I know that? Because we have highest degree term is x squared. So the graph is a parabola opening downward. Very good. And they want the max profit. Well, that's going to be at the vertex. So again, we have to find the vertex. That's the theme or the name of the game for these parabolas that open down. Okay, so h is -b, -16 over 2a, so 2 times -4. So that's 16 over -8, which is -2. That's not the max profit though. That's the x value that gives me the max profit. To get the max profit, I have to plug that in for x. So p of -2 is -4 times -2 squared minus 16 times -2 plus 12. So that's -4 times +4, -16 plus 32 plus 12, which is what? -16 plus 44, 28. But this is in thousands of dollars, so the max profit is $28,000. All right, good. How are you doing? I have one more. The manager of a peach orchard is trying to decide when to arrange for picking the peaches. If they are picked now, the average yield per tree will be 100 pounds, which can be sold for 80 cents per pound. Past experience shows that the yield per tree will increase about 5 pounds per week, while the price will decrease about 4 cents per week. Okay, so right now a tree has 100 pounds worth of peaches on it. That's the quantity of peaches, basically. And every week, that tree is going to have 5 more pounds of peaches on it. Cool. If he sells the peaches now, they'll sell for 80 cents a pound. Every week that he waits, the price goes down. So after 1 week, he can only sell them for 76 cents. After 2 weeks, he can only sell them for 72 cents, like that. So you can see it's tricky. They're not worth as much as time goes on, but he's got more peaches. So we have a little game to figure out for Mr. Farmer, or manager of the peach orchard. Part A, let X represent the number of weeks that the manager should wait. Find the income per pound. Okay, so at the very beginning, if he's waiting 0 weeks, right now, today, if X is 0, how much can he sell the peaches for? 80 cents. I don't like decimals in my equation, so I'm just gonna leave it as 80 cents and we'll work with 80 in the equation. Each week, he can sell them for 4 cents less. So the price goes down by 4 cents. Now, I know they said find the income per pound, but it's basically the price per pound that we're charging. So if you want to call it I of X, feel free. But it's the same thing as your price per pound, little p of X. And it's going to be 80 if he doesn't wait at all, minus 4 cents for each week X that he waits to sell it. Okay, marinate, are you good? It's basically like your demand equation. Okay. Part B, find the number of pounds per tree. So they're calling this quantity yield, okay? But it's also just referring to the quantity of peaches, of pounds of peaches per tree. So if we don't wait at all, because remember, X is the number of weeks that the manager should wait. If we don't wait at all, each tree has 100 pounds. For every week that we wait, the tree has 5 more pounds. So the yield, or the quantity, we can call it Y of X or Q, same thing, or X, is going to be 100 plus 5 for every X we wait. So this yield tells me, aka the quantity of peaches. Okay, how are we doing? Good. Find the total revenue from a tree. So the revenue formula that we've looked at before, R of X, in previous lesson, was that we had X times P of X. So X represented the quantity of a good that was sold, and P of X is the price. So in this case, my quantity isn't just plain old X, it's actually Y of X. There's more going on. And then the price is, we have over here, the income, the price. So now I'm going to write out in the context of this problem, revenue equals I of X times Y of X, okay? So the revenue is going to be 80 minus 4X times 100 plus 5X. And then all we need to do from here is FOIL, so distribute everything. This is going to be 8,000 plus 400X minus 400X minus 20X squared. Ooh, barely fit. So then R of X, you see how the 400X's cancel? Here's a positive, here's a negative. It's going to be 8,000 minus 20X squared. Beautiful. Okay. When should the peaches be picked in order to produce maximum revenue? So remember, if I want to maximize the revenue function, which is right here, it's quadratic. This is A. A is negative 20. So if we were to graph revenue function, it's a downward facing parabola. How do we find the max? we find the vertex. That's right. So they're asking for when. I just need the x coordinate of the vertex. I just need h. Negative b over 2a. There is no b. If you want me to rewrite revenue, maybe it'll help you. It's negative 20x squared plus 0x plus 8,000. So you see how b is 0? Good. 2 times, well, who cares? 0 divided by anything that's not 0 is 0. Oh, so what does that mean? The revenue is maximized when x is 0. So when should he pick the peaches? Now. Don't wait at all. Oh my God. Quick. Pick them peaches. Okay. What is the maximum revenue? So now we're actually going to substitute in 0 for x into the revenue function. We have 8,000 minus 20 times 0. So 8,000. Oh, but remember, I used everything in cents. So 8,000 cents. It's not $8,000. It's only $80. But remember, that's per tree. I don't know how many trees are on this little orchard. Maybe quite a few. Maybe $80 per tree isn't so bad. I don't know. So that concludes the video. Hope you enjoyed it. Give it a thumbs up. Subscribe if you haven't already. And there will be more business calculus video lectures coming soon. A lot of this content right now is just reviewing some of the earlier math skills to get you ready to dive into the calculus that's coming, along with some, like little finance econ applications here. So I hope you're enjoying this new content, and check out the rest of my playlist on my YouTube channel. I have videos on algebra, pre-calc, calc 1, 2, 3 primarily. That's my bread and butter. If you just need help with study tips and skills and student life, go to the playlist Ask Professor V. And if you love integrating, if you know what that is, there's an integral of the day playlist that I actively update. Thanks so much for your support. Follow me please on Instagram, TikTok, Math with Professor V. I love you all so much. I'll be back sooner than later. Bye.